Welcome back to my channel, friends. Today we will work out the solutions of the problems 5, 6 and 7. So the problem, let's start with problem number 5. It says that the three vectors are given, namely OA, BC and DE, with this kind of orientation as shown in figure. Now we are directed to find the magnitude, the x and y components, and finally the angle with x-axis of the resultant of OA, BC and DE. Therefore, let us solve this problem. So x component of OA is equal to 2 cos 30 degree, as it is evident from the figure, and BCX would be 1.5 cos 120 degree, as is evident from here, and there will be no component of D along x. So by calculating we get OAX, that is the x component of OA, it is equal to √3. The x component of BC is equal to minus 0.75. Here negative sign indicates that it is its direction will be along the negative x-axis, and x component of D is equal to 0. Similarly, when we find the y component of OA, BC and DE, it will be OA sine 30 degree, that is the magnitude of OA sine 30 degree to be precise, is equal to 1. And in similar way, we get the y component of BC to be 1.3 and y component of D to be minus 1. Then the x component of R is equal to x component of OA plus sorry, it is written wrong. The x component of OA plus x component of BC plus the x component of DE. So it becomes √3 minus 0.75 plus 0, and since its unit is meter, so it is meter, is equal to 0.98 meter. And the y component of Ry, simply we add the y components of the individual vectors as done in case of the x components, that is equal to 1 plus 1.3 minus 1 meter is equal to 1.3 meter. Therefore, the resultant, that is the magnitude of the resultant R, is equal to root over Rx square plus Ry square. Rx is the magnitude of Rx vector and Ry is the magnitude of Ry vector. That is x component and y component. Calculating we get 1.6 meter. Now to get the angle that the resultant R makes with the positive direction of x-axis, let's say it is alpha. Therefore tan alpha is equal to Ry by Rx is equal to 1.3 by 0.98 is equal to 1.32. Therefore alpha is equal to tan inverse 1.32. You can calculate it using scientific calculator. Now coming to question number 6. It says, let there be two vectors with magnitudes 3 unit and 4 unit respectively. Find the angle between them if the magnitude of the resultant is 1 unit, 5 unit and 7 unit. That is, they are the resultants. So in the first case, R is equal to 1 unit and let theta be the angle between them. Therefore 1 equal to theta be the angle between them, the theta is assumed here. Therefore, using the formula R is equal to root over a square plus b square plus 2ab cos theta under root, we get 1 is equal to root over 3 square plus 4 square plus 2 into 3 into 4 cos theta, and calculating we get cos theta is equal to minus 1, thereby theta is equal to 180 degree. You can take a screenshot of this calculation if necessary. Now in case r is equal to 5 unit, we get 5 square is equal to root over 3 square plus 4 square plus 2 into 3 into 4 cos theta. Here theta will be different obviously, whole square. So 25 is equal to 25 plus 24 cos theta, therefore cos theta is equal to 0. Now cos 90 is also equal to 0, so here theta is equal to 90 degree. Now if r is equal to 7 unit, then 7 square, that is 49, is equal to 3 square plus 4 square plus 2 into 3 into 4 cos theta. So calculating, we get theta is equal to 0 degree. So in first case, the angle between the two vectors are 180 degree. In second case, it is 90 degree, and in the last case, the angle between them is 0 degree. Now question number 7 says a car moved 2 kilometers towards the east, then made a perpendicular left turn and ran for 500 meters, that is 0.5 kilometer, then made a perpendicular right turn, that is again towards east, and then ran for 4 kilometers and stopped. Find the displacement of the car. Now see, the whole situation is shown in the figure here. You can see that, and we have taken a positive x-axis along the east direction and the positive y-axis along the north direction. Then from the figure, the displacement vector is AD, and let AD makes an angle theta with the positive x-axis. Now coming back to the sum. Now AD is the displacement, is equal to 2i cap plus 0.5 j cap plus 4i cap in kilometer is equal to 6i plus 0.5 j kilometer. So it is since displacement is a vector term, so it is all right. So its magnitude is AD is equal to root over a square. As you can see, root over a square plus root over d square. Root over a square plus d square. Now d is a y component of the displacement, and a is the x component of the displacement. Calculating, we get is equal to AD is equal to 6.02 kilometer. Now let theta be the required angle. Therefore tan theta is equal to, as shown from evident from the figure, it is d over a is equal to 0.5 over 6 is equal to 1 over 12. Therefore theta, that is the angle between AD and the positive x-axis, is equal to tan inverse 1 over 12, whose value can be calculated using calculator. Therefore the displacement of the car is 6.02 kilometer. It is the magnitude, and for the direction, it is along the direction tan inverse 1 over 12 with the positive x-axis. So that's all for today, guys. Kindly do like, share, subscribe for more such videos. Thank you.